Good morning, students. Today we are going to study about your mathematics chapter, Be My Multiple, I'll be your factor. Okay? So you will have your own data in your book, that is your math magic. But before going to your subject, let's learn the concepts first. Okay? So as we know, to cook something, we should know about the vegetables first. So let's talk about number system and your multiples and factors. What are all these things we should know before going to your chapter Be My Multiple, I'll be your factor. You are all in class 5, so you must have known about the number system. Your number system starts with your natural number series, whole number series, which we deal with. Okay, so what is then the multiple? Let's take the example first. We know about the multiplication table, isn't it? We all know about table, just like for example 2 table, 2 into 1 is equal to 2, 2 into 2 is equal to 4, 2 into 3 is equal to 6, 2 into 4 is equal to 8, 2 into 5 is equal to 10, 2 into 6 is equal to 12, 2 into 7 is equal to 14, 2 into 8 is equal to 16, 2 into 9 is equal to 18, and 2 into 10 is equal to 20. So is there any relationship? Can you find it? See, I have 2 in my left hand side and I am multiplying it with a natural number series 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we know that natural number series goes to infinity. So why do we stop here actually? This is a multiplication table, but this is not the end of the multiplication. We are multiplying the natural number series from 1 to 10 only, but we can multiply up to infinity, just like for example 2 into 100 gives us 200, 2 into 150 gives us 300, and so on. We can keep on going. So this is not the end of it. And what all these numbers are related with 2? See, these all are the multiples of 2, because these all numbers are completely divisible by 2. So 2 is the smallest possible multiple of 2. So from this we come to know that every number is a multiple of itself. When we multiply any number with 1, we get the number itself. So it is the smallest possible multiple of any number. For example, 5. When we multiply 5 with 1, we get 5, which is the smallest multiple of 5. So it is clear that every number is a multiple of itself. We know about the divisions. For example, 15. 15 is divisible by 3. 5s are 15. 0. 15 is also divisible by 5. 3s are 15. It also gives us 0. 15 is also divisible by itself, and it also gives the remainder 0. From this, see, we are finding out a relationship. See, when I divide any number with another number, and if it gets 0 as the remainder, then this number is completely divisible by 3. 15 is completely divisible by 3. So any number, if it divides another number completely, giving 0 as the remainder, that means 3 is the factor of 15. 3 is the factor of 15. So I can say, okay, any number, take any number. Let's take another number, that is suppose 30. 30 is a number. Can you tell me by which number 30 can be divided? Yes, 30 can be divided by 1. 1 30s are 30. 0. 30 can be divided by 2. 15s are 30. 30 can be divided by 3. 10s are 30, and so on. We can keep on dividing by many numbers. So those numbers are called the factors of 30, because 30 is completely divisible by all these numbers 1, 2, 3, 5, 6. The number series in which 30 lies, the multiplication series in which 30 lies. or we can say the multiplication table of any number in which 30 lies is a factor of 30. We can take on so many examples like this. So what is happening actually in case of multiples and factor? Let's check. See, I am writing down the multiples of 2 first. 2, 4, 6, 8, 10. Can you find a series? Can you find the relationship between all these numbers? I hope so, because all these numbers are with a difference of 2. Starting from 2, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. That means in case of your multiples, they go on with an increment of the starting number itself. For in case of 3, let's check. Is it happening so? 3, 6, 9, 12, 15. See the difference. 3 plus 3 plus 3 plus 3, and it will go up to infinity. Now we can say that to get the multiples of any number, we can multiply that number with the series of natural numbers. You can also find out the multiples of any number by multiplying that number with the series of natural numbers. That means every number has infinite number of multiples. We cannot say that a number has this many number of multiples only. The any number, let it be any number, it has infinite number of multiples, because how we get the multiples? When we multiply that number by itself. See, 2 2s are 4. Again, 2 3s are 6. 2 4s are 8. 2 5s are 10. That means I can represent in a simple way. The multiples can be represented in a very simple way. That is, any number multiplied with the natural number series. Any number, the natural number series, the set of natural number stands with capital N. So let's check. It starts with 1 and goes to infinity. The natural number series starts with 1 and goes to infinity. 1, 2, 3, 4, 5 and so on up to infinity. That means when I multiply this number, let this number be any number, let it be 2, 3, 5, 515, 2017, anything. So the multiples will be the multiplication of that number with the natural number series. For example, 2. If I multiply 2 with 1, 2, 2 with 2, 4, 2 with 3, 6, 2 with 4, 8 and so on. So as the natural number series goes to infinity, so any number has infinite number of multiples. So what is the relationship between a multiple and a factor? I think till now you might have understood. Let's check. As I told you first, that a number, if it is divisible completely by another number, is called a multiple of that number, and the divisor which divides that number is called your factor. Let's check. See, 15, it is completely divided by 3. 5s are 15, 0. So when we divide 15 with 3, we get 0 as the remainder. That means 15 is completely divisible by 3. 15 is completely divisible by 3. That's why 3 is called a factor of 15 and 15 is called the multiple of 3. That means 15 is saying, hey 3, you want to be my factor, then you need to divide me completely, and giving remainder 0. Okay, 3 says, okay, I can divide you completely. There is no problem. If I am dividing you, I will give you remainder 0. So let me be your factor. 15 says, okay, done, you are my factor. So if you are my factor, then accept me as your multiple. If you want to be my factor, then please be my multiple. 3 also agrees, they shake hand and they have a relationship between themselves. 15 is a multiple of 3 and 3 is a factor of 15. If 4 comes, what happens when 4 comes? 4 3s are 12, giving remainder 3. So 15 says, hey 4, sorry, you can't be my factor because you are giving me remainder as 3. You are not dividing me completely, so you can't be my factor. I can't be your multiple, so we can't build up a relationship. Bye-bye. So students, we have learned the concepts of multiples and factors. We have created the relationship between multiples and factor. So we know that if a number is multiple of another number, that number has to be a factor of the number. Okay? So let's connect the concepts with the chapter Be My Multiple, I'll Be Your Factor from the book Mathemagic, and that is your chapter 6. So it contains many stories, and the first story goes the mouse and the cat. Have you gone through the story? I hope so. So what's happening over there? What you found? Did the cat able to catch the mouse? Let's check. So as per the story, the mouse is on 14th step and it can jump 2 steps, and the cat, it is on the 3rd step and it can jump 3 steps. So what will happen now? If the cat can jump 3 steps, it can move from 3 to 6 to 9 to 12 and so on. As we have already studied, they will go with the increment of 3 because it is allowed to jump 3 steps only. So it will move with an increment of 3 steps, and it can move from 3 to 6 to 9 to 12 to 15 to 18, 21 and so on. And the mouse, it is allowed to move 2 steps and it is now on 14th step. So 14, from 14 it will go to 16, 18, 20, 22 and so on with an increment of 2 because it is allowed to move 2 steps. So what you feel? Whether the cat can catch the mouse? Let's see. It is the cat and here goes the mouse. It starts from 3, it starts from 14. Let's check the steps. 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay? Let's check for the mouse. 14, 16, 18, 20, 22, 24, 26. Okay? So can you find the relationship whether the cat is catching the mouse or not? So let's see what is happening with the mouse, whether the cat is able to catch the mouse. So as we know, the mouse is allowed to jump 2 steps and the cat is allowed to jump 3 steps. So in the first jump, what happens? The mouse goes from 14 to 16, but the cat goes from 3 to 6. Same way, up to the 6th step, when it comes to 6 steps, the mouse is on 26th step, but the cat is at 21st step. So on the 7th jump, the mouse will move to 28, but the cat is still on 24th. So in this way, if they keep on going, the cat will never be able to catch the mouse. But one thing is for sure that both of them, the cat and the mouse, they come to the 24th step. But you need to remember that this 24th step, mouse comes at its 5th jump when the cat comes at its 7th jump. So they will not be able to meet each other. That's why the cat will never be able to catch the mouse. Okay? So from this we can come to understand that, see, this is 3 and this is 2. So which all numbers are lying in this column? The cat goes with 12, but mouse starts with 14. The cat comes to 18. See, here we have 18. The cat comes to 24. Here we have 24. So 2 and 3, they both meet each other at 18. That means 18 is multiple of 2 as well as multiple of 3, because 18 is completely divisible by 2 as well as 3. Same way 24. 24 is also a multiple of 2 and 3, because 24 is also completely divisible by 2 as well as 3. So, students, the next story is, who is Monto waiting for? Monto, who is it? Monto is a cat. So, for what is it waiting for? I hope for a mouse, isn't it? Let's check. So, you have a group of numbers, colorful numbers, colored in different colors. So, what we need to do, you can do it with myself, okay? Mark with a red dot all the numbers which are divisible by 2, okay? Mark a yellow dot all the numbers which are divisible by 3, and mark with a blue dot on the numbers which all are divisible by 4. So, when you mark, just start marking quick. You can mark it, you can do it, and you can find some of the numbers, okay? Some of the numbers are all these 3 dots. Which all dots? The yellow dot, the red dot and blue dot. So, can you find any letter over that number? Yes, you can. Obviously, see, you can find the letters M, O, U, S and E. That goes for mouse. So, students, which all numbers we found from the group of numbers? M is found at 12, O is found at 24, U is found at 36, S is found at 48 and E is found at 60. So, how we found it? By putting dots. All the 3 dots, they lie in these numbers. The dots for 2, 3 and 4. So, what does it mean? It means all these numbers are nothing but common multiple of 2, 3 and 4. That means these numbers lie in the table of 2, 3 as well as 4. You can check it by yourself, okay? So, what was he searching for? Monto was actually waiting for a mouse which was hidden in all these numbers. Now, it has got that mouse, and what it is going to do with that? I don't know. I think you might be knowing by looking around your surroundings what a cat does with a mouse, isn't it? You must have seen around what a cat does with a mouse, okay? So, let's go to the other activity, that is the Mew game. Let's play a game now. It's a game time, okay? So, you just go through the story. What it says, that the player who has to call 3 or a number which can be divided by 3 has to say meow. Instead of the number, one who forgets to say meow is out of the game. So, can you guess which all numbers are there on which the kids have to say meow? Yes, these all numbers are the multiples of 3. So, they have to say meow at 3, 6, 9 and so on. So, all these numbers are called the multiples of 3, because these all numbers are completely divisible by 3, giving remainder as 0, as we have already discussed. Okay? So, students, let's play the dice game. Okay? I hope you all have played Ludo at home, isn't it? It has single dice. So, today we will play with 2 dices. So, we know the dice has all 6 numbers 1 to 6. Students, when we roll 2 dice, each dice gives us a number. The numbers may be same or different. So, for example, if the first dice gives us 1 and the second dice gives us 2. So, we get a 2-digit number 12. Now, think this number 12 lies in which of the table? 6, 4, 5 and 7. See, it lies in 6 as well as 4. It lies in 6 as well as 4. 6 2s are 12, 4 3s are 12. So 12 is a multiple of 6 and 12 is as well as the multiple of 4. So we find that 12 lies in the tables of 6 as well as 4. 6 2s are 12, 4 3s are 12. So 12 is a multiple of 6 as well as 4. Let's roll again. This time suppose it gives 3 and 4, 34. 34. Does it lie in any of the tables? No. See, it doesn't lie in any of the tables of 6, 4, 5 and 7. That's why it is not a multiple of 6, 4, 5 or 7. Let's roll again. Suppose this time it gives us 36. Who gets a 6? Oh, such a winner he is. He gets a 6, the red dots. 36. So it lies 6 6s are 36. So 4 9s are 36. So 36 is a multiple of 4 as well as 6. Let's roll down again. Suppose this time I get 25. So what happens with 25? 25 is in the table of 5. 5 5s are 25. So 25 is a multiple of 5, but it's not in the table of 6, 4 or 7. So it is not a multiple of 6, 4 and 7. Let's roll it again. Suppose this time I get 14. So in which table does it lie? It lies in the table of 7. 7 2s are 14. So 14 is a multiple of 7. Now check which are the factor. So 6 is a factor of 12. 4 is also a factor of 12. 6 is a factor of 36. 4 is also a factor of 36. 7 is a factor of 14. 14 is a multiple of 7. 5 is a factor of 25 and 25 is a multiple of 5. Students, hope you enjoyed this game. Now let's check about what all are the common multiple. Let's go. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12, 2 7s are 14, 2 8s are 16, 2 9s are 18 and 2 10s are 20. 3 1s are 3, 3 2s are 6, 9, 12, 15, 18, 21, 24, 27 and 30. 4 2s are 8, 4 3s are 12, 4 4s are 16, 20, 24, 28, 32, 36 and 40. Let's check the rows. So now check the common multiples. Let's check for 2 and 3. Let's check which all numbers lie in the row 2 and 3. First is your 6. Next is your 12. Then your 18. So these all numbers 6, 12 and 18, they lie in the tables of 2 and 3. So 6, 12 and 18 are common multiples of 2 and 3, and we can as well as say that 2 and 3 are factors of 6, 12 and 18. Let's check for 4 whether it has any common multiple. Let's check. Okay, we have 12 over here as well. So this 12 is a common multiple of both 2, 3 and 4, and 12 has common factors 2, 3 and 4. Clear, students? We have now gone through the book up to common multiple, and we have played a meow game, and your next class will cover the rest part of the chapter. Till then, keep practicing, keep learning and stay safe and keep smiling. As if you are happy, then you have a fresh mind and you can do maths tremendously. What we have learned actually? We have learned about the factors and the multiples and their relationship, how they shake hand and go together. They can't live without each other. A multiple has to have some factors, and factors, they have some multiples. But nevertheless, all the numbers, they do not have all the factors. They have some common factors and some factors have some common multiples. So all these things we have discussed. Hope you understand, and see you again in the next class. Thank you.